Hello everyone. In this session, we will discuss about measures of dispersion. Now we will go into the session. In this session, we'll see about measures of dispersion. Measures of dispersion is classified into two. One is absolute measures, another one is relative measures. And four absolute measures are there: range, mean deviation, about, an average, let us say A, an average A, capital A. I'll put it as capital A. So here that A can be either mean or a median or a mode. It can be any of these three averages. Then next one is standard deviation, which is denoted by the symbol sigma. Then quartile deviation, shortly written as QD. And even this mean deviation is shortly written as MD suffix A. Then the corresponding relative measures are coefficient of range, coefficient of mean deviation about an average A, coefficient of variation. Generally, this is written as CV and it is calculated in terms of percentage. Then coefficient of quartile deviation. Now we will see what are all the formulas to calculate each of this. First one, range. Range in a data is nothing but highest minus lowest, where H is the highest value and L is the lowest value or the least value. Then the corresponding relative measure, which is coefficient of range, is highest value minus lowest value divided by highest value plus lowest value. When you say relative, it is about a comparison. So here the comparison is between the range divided by sum of the highest and lowest. So it is generally in the form of a ratio. Then next one, mean deviation about an average A. That is calculated as summation of absolute value of the observation minus that average divided by number of observations. So I can say where X is the observations, each observation, and A is the average. That average I said already, it can be mean or median or mode. And N is the number of observations. This formula is applicable for a non-frequency distribution. I can say the above formula is applicable for non-frequency distribution because this formula do not have any F in it. Non-frequency distribution. Then if it is a frequency distribution, the formula will change a little. MD suffix A. If it is a frequency distribution, then in the summation, you will also multiply the frequency, corresponding frequency into that modulus of X minus A, or you can say absolute value of X minus A divided by, instead of small n, it will become capital N. So I can say where f is the corresponding frequency and capital N is sum of all the frequencies. So this is, I can say, the above formula is applicable, sorry, is applicable for frequency distribution. Frequency distribution. Right. So we saw two different formulas for mean deviation about an average. Okay. Next is coefficient of mean deviation about an average. That is calculated as whatever mean deviation about an average what you calculated divided by the average. That will become your coefficient of the relative dispersion. Then next formula is for standard deviation, sigma. I wrote already here, standard deviation is denoted by sigma. First, we will write the formula for a non-frequency distribution. It will be square root of summation x minus x bar, the square divided by smaller n. If you look into this can be expanded, like it is like a minus b the whole square. So you expand it and then simplify it. So once you do that, this also can be written as square root of summation x square by n minus x bar the whole square, where x bar is the arithmetic mean, x is observations, denotes observations, and n is the number of observations. So this is standard deviation. I can write the above is applicable for non-frequency distribution. When the data do not have any frequency involved in it, you use this formula. Then the next formula, sigma is equal to square root of summation f multiplied by x minus x bar, the square divided by capital. You may notice there is a similarity between this, and this. So what we did is the numerator is getting multiplied with f and smaller n has become capital N. Again, this again can be expanded as a minus b the whole square. So this formula can also be written as square root of summation f into x square by capital N minus x bar the square. This formula you will use if it is a frequency distribution. The above is applicable for frequency distribution. For a frequency distribution. Where capital N is the sum of the frequencies. X bar is again arithmetic mean. So here and here the formula will differ here it will be sum x by n, means here arithmetic mean is without frequency. So sum x by smaller n, whereas here it will be with the frequency, it will become sum fx by capital N because it is involving frequency. Oh, sorry. Next is h. I will write one more a note. Square of standard deviation. Square of standard deviation. That is sigma square is called variance. Is called variance. That is a note. Then we have next formula h. It will be coefficient of variation. Coefficient of variation denoted as CV is standard deviation divided by arithmetic mean multiplied by 100. So this is in percentage. Generally, coefficient of variation is calculated in terms of percentage. This is very useful measure, very useful relative measure, especially to see whether which series of data is more consistent or which series of data is more variant. Means, for example, I can say, note, CV is used to check as which series is more consistent or more variant. So, for example, if X, Y, Z are three different series of data, three different series of data, and if let us say we calculate coefficient of variation of X, and then you also calculate coefficient of variation of Y, coefficient of variation of Z. You calculate all the three using that data. Means first I have to find out what is the standard deviation of X, what is the standard deviation of Y, what is the standard deviation of Z, what is the arithmetic mean of X, what is the arithmetic mean of Y, what is the arithmetic mean of Z. After you calculate all those things, you can able to calculate the coefficient of variation of all the three variables. And then if you find CV of X is lesser than CV of Z and it is lesser than CV of Z, I'm sorry, CV of Y, CV of Y, then we can conclude, that X is more consistent than Z and Z is more consistent than Y. That is one conclusion we can do. Also, we can conclude that Y is more variant than Z, and Z is more variant than X. So that way it is being used. This coefficient of variation is used in that way. Just a minute. So till coefficient of variation we did right. This is what H till H we did. Okay. Now next one is quartile deviation. QD can be calculated as Q3 minus Q1 divided by 2. So if you look into that numerator, it is actually quartile range, because the maximum quartile is Q3, minimum quartile is Q1. You can also call it as quartile range. Which one? The numerator. Divided by 2. Since you are dividing it by 2, this quartile deviation can also be called as semi-quartile range. Quartile deviation can also be called as semi-quartile range. Why semi? Because it is actually quartile range is getting divided by half for that reason. Then the next one, coefficient of quartile deviation. That can be calculated as Q3 minus Q1 divided by Q3 plus Q1. It is very similar to coefficient of range where you wrote H minus L by H plus L. Here also you are writing Q3 minus Q1 divided by Q3 plus Q1. So these are the various measures of dispersion. So in case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.